Hey guys, so today we are going to be in Chapter 8, Section 2, the last section of Chapter 8 that we're really going to talk about, which is arithmetic sequences. So arithmetic sequences are sequences in which each term after the first term differs from the preceding term by a constant. And that difference is called the common difference. If you look at the word arithmetic, you'll notice it looks a lot like the word arithmetic. And that's because you're going to use arithmetic or addition and subtraction in order to come up with what each of the next terms are. One of the most popular ones, or maybe well-known ones, is the Fibonacci sequence. That is an arithmetic one, but you have to know the first two terms actually for that one, because you have 1, 1, 2, 3, and where you're adding the two previous terms. But arithmetic sequences have a common difference. So I've listed 3 different arithmetic sequences for you. So that first one is 142, 146, 50, 140, or 154, and so on and so forth. So if you notice, you're increasing by the same thing every single time. And what is that? Well, that's your common difference. The way to find your common difference is simply to take 2 of the terms and subtract them from each other. So take your second term, subtract from that your first term, and that'll give you your common difference. So 146 minus 142, there's a common difference of 4. Notice it's positive, which means that every term you're going up by 4. The next one, we have -5, -2, 1, 4, and 7. Again, if you take the second term, so -2, minus the first term, that's a -5, that becomes -2 plus 5, which becomes a +3. So you're going up by 3 every time. The last arithmetic sequence is 8, 3, -2, -7, -12, and so on and so forth. Again, second term is 3, subtract from that your first term, which is 8, and you get a -5. So in this case, we are going down by 5 units every single time we go through our sequence. So that's an arithmetic sequence. It follows the set pattern. So what we're going to do is we're going to find some of the first terms for an arithmetic sequence. Right. It says write the first 6 terms for this arithmetic sequence. It tells us that our first term is 6 and that our equation for the nth term is a to the n minus 1 minus 2. So that's the terms, like we need to come up with the second, third, fourth, fifth, and sixth. On your homework, if it asks for the first 6 terms, there will be a spot for the first term, even though they're going to give it to you. So be careful with that you don't write down the second term as your first term, because you're thinking that's the first one you found. They give you the first term. So on your homework, make sure you do that correctly. So what this means is if we're trying to find the second term, then we're going to have a to the first term minus 2. Okay? So we're going to have to take that first term and subtract 2. So if you wanted to write that out in general, you could say a to the first minus 2. Well, the first term was 6, take away 2, so my second term is 4. If I'm looking at my third term, if a to the third, so that would be a to the 3 minus 1, that'll be a to the second minus 2. Well, our second term was 4, minus 2 will be 2. Same thing for our fourth term. You're going to have to know your third term and take away 2. My third term was 2, and I take away 2, I get 0. To find my fifth term, I have to know my fourth term, take away 2. Well, my fourth term was 0, take away 2 is -2. And for my sixth term, I have to know my fifth term and take away 2. My fifth term was -2, and I take away 2. That'll give me a -4. So there is the first 6 terms of this arithmetic sequence. So if we look on the notes, which I have shared with you, there is a general term for the arithmetic sequence, which is pretty much We have part of it right here. But the general term says that for the nth term, we have to take the first term and add to that n minus 1 times our common difference. So we need to have that ready to use in case we need to find some of these other ones. So let's move you down and you can see which the example that's right here is the example that's on the very bottom of this page that you can see. So it says we're going to find the 8th term of the arithmetic sequence, which the first term is 4, and the common difference is a -7. So anytime I have to find a specific term of an arithmetic sequence, I'm going to write the general form first. A to the 1 plus n minus 1 times our common difference. So in this case, it told me that my first term was 4. It told me my common difference is -7. And it told me that I want the 8th term. So my n is 8. Now that I have all of that information, I can simply plug it into my general form and come up with the 8th term. So a to the 8th equals a to the first, which was 4, plus my n, well, I'm trying to find the 8th term, so that's n minus 1, times my common difference, which was a -7. So the 8th term of this sequence is going to be 4 plus 8 minus 1 is 7 times -7, which is 4, 7 times a -7 is a -49. That's -45 is the nth term of that arithmetic sequence. And we were able to find that using this general form, which is so much nicer than having to find every single one of those. Yeah, this was only the 8th term, but what if I asked you to find the 800th term? You definitely wouldn't want to sit there and write out 800 terms of that sequence. So having this general form to find this term is so much nicer, so that we don't have to do all that extra work just to find a single term. We're going to do another example. Same exact style of problem. This time we're going to find the 9th term when the first term is 6 and our common difference is 5. So again, I'm doing a to the n equals a to the 1 plus n minus 1 times d. Just like with any form or formula or equation, every time I use it, I'm going to write it down because that gets it in my brain and that helps me to memorize it. So I'm finding the 9th term. So my n is 9. My first term they told me was 6. My n is 9. And my common difference is a -5. That's 6 plus 9 minus 1 is 8 times the -5. So that's going to be 6. 8 times -5 is a -40. 6 minus 40 is a -34. That is the 9th term of this arithmetic sequence. Now, this has worked out pretty good. We find the specific term, but what if we are given a list, like a sequence, and then we're asked to come up with like the general formula for that instead of using the general formula to come up with a term? So like almost backwards of what we've been doing. Well, we can do that. It's not as hard as you would think. And I scrolled down so you can see it, but it's also right here on the board. So we're going to write the formula for the nth term for this arithmetic sequence. We go -2, 8, 18, 28, so on and so forth. And maybe by looking at that, you can come up with the information you need. But what we need is we need our first term. Well, the first term is -2. And we need our common difference. So our common difference is how is our sequence changing every time? Well, if you're not sure, then what you do is you take your second term and subtract your first term. So second term and subtract the first term. So that's 8 minus a minus 2, which is 8 plus 2, which is 10. So our common difference is 10, which in this case, hopefully that's a little bit obvious as you go from 8 to 18 and 18 to 28. Hopefully you can tell you're going up by 10. Now that we know our first term and we know our common difference, we can plug those two things into our general form, that a to the n, and come up with our formula for the nth term for this specific arithmetic sequence. Because it's a to the n equals a to the first plus n minus 1 times d. Now, we don't have an n in this case because we want to figure out the formula for the nth term. So we're not going to be able to substitute in an n, but we can substitute in for our a to the first. That's -2 plus n minus 1. And then our common difference we just found is 10. So times 10. So a to the n equals a -2. And then I'm going to distribute this 10 into my parentheses. So it'll be plus 10n minus 10. So a to the n equals 10n, and then I have a -2 and a -10, which is a -12. So right there is our general form or a general formula for this specific arithmetic sequence. So now with this, I can find any of the terms that I needed. If I needed to find the 12th term, then I would just type in 12 and I would be able to come up with it. If I had to find the 1200th term, I could do that as well. And so this makes it a lot nicer. We're going to do another example of that because this is a little bit different than just plugging it in and trying to come up with a specific term. This we're finding the very general form in order to find all the terms that they may have ever asked us for. So again, I scrolled up on the notes so that you could see it on your screen, but it's also right here. We're going to find the formula for the nth term for -4 to 2, 8, 14, so on and so forth. My first term is -4. My common difference is going to be 2 minus a -4, which is 2 plus 4, which is 6. So the general form is a to the n equals a to the first plus n minus 1 times the common difference. So we plug in everything we know. We know a to the first is -4. We're keeping it in general terms, so we have the n minus 1. And then my common difference we just found was 6. Again, I'm going to distribute that 6 inside the parentheses. So I have a to the n equals -4 plus 6n minus 6. So I have a to the n equals 6n, and then -4 -6 equals a -10. So there is the general formula for the nth term for that specific arithmetic sequence. Okay, so now we're going to talk about a slightly different topic that is very similar to what we talked about in 8.1. Sorry, I'm trying to move this over a little bit. There, that way it says sum. We're going to talk about the sum of an arithmetic sequence, or the sum of the first n terms. So in 8.1, we learned summation. That's with the funky looking E with the sigma. And we learned how to do that, where we take all the terms and we add them all together, and it tells us the sum of the first so many terms, which that was great. The problem with that is if we had to find the sum of the first 100 terms, then we'd have to actually find all those terms, then add them together. This new sum is very, very nice because all we have to find is the first and the last term. We don't have to find everything in between. And so what this is this capital S with a subscript of that lower n. And what that n is that tells us the first n terms. So the first n number of terms. So the sum of n equals n divided by 2 times a to the 1, which is the first term, plus a to the n. That's the last term of that thing that we're finding, okay? So it's going to make a lot more sense when we actually do one of these problems. So the first one we're going to do is we're going to find the sum of the first 100 terms of 1, 3, 5, 7, so on and so forth. So we're going to find the sum of the first 100 odd numbers. Now, using the steps for summation, we would have to list every single one of those, the first 100 terms, and then we'd add them together. That's how we have to do it. But now with the sum, we don't have to do that. So here's what we're gonna do. I'm gonna write S of n equals n over 2 times a1 plus an. So what we have to know is we have to know our first term and we have to know our last term. So our first term is easy because that's a sub 1, which is 1. They give us that. But now we also have to know our a sub 100 because we want the first 100 terms for this sequence. So what do we do there? Well, we use our general form that we've been using this whole time. That's our a sub 1 plus the n minus 1 times the common difference. We're going to use that to come up with our 100th term. Well, our a sub 1 is 1 plus our n minus 1, so that's 100 minus 1. And then our common difference, well, we're going from 1 to 3 to 5 to 7, so we're going up by 2 every single time. So our common difference is 2. So that equals 1 plus 99 times 2, which equals 1 plus 198, which equals 199. This is the 100th odd number. So that's what our 100th term. So we are trying to find S, the sum of the first 100 terms of this sequence. So 100 is our n, so that's 100 divided by 2 times our first term, which is 1, plus our nth term, which we're finding the first 100, so it's a sub 100, which is 199. 100 divided by 2 is 50. 1 plus 199 is 200. So 50 times 200 equals 10,000, which to me is kind of crazy. Because if you think about 100 terms, you wouldn't think that the first 100 odd numbers would really amount to all that much, but it adds up to 10,000. And I don't know about you, but I think this process is so much nicer than the process we had earlier where we were using the summation and having to list out every single one of those. We're going to do another one. We're going to find just the sum of the first 15 terms of 3, 6, 9, 12. So these are our multiples of 3. So my first term is 3, and I need to find the 15th term because I have to find my first term and my last term. And if I'm finding the first 15 terms, then a sub 15 is my last term. Turn that a little bit more. So to find that, I take a sub 1 plus n minus 1 times the common difference. A sub 1 is 3 plus n minus 1, which is 15 minus 1, times the common difference. If I'm going 3 to 6 and 6 to 9 and 9 to 12 and so on, I have a common difference of positive 3. 3 plus 15 minus 1 is 14 times 3. So that's 3 plus 42 equals 45. So my first term is 3 and my nth term is 45. So now I'm going to find S sub 15. Well, that's going to give me n over 2, which is 15 over 2, times the first term, which is 3, plus the 15th term, or the last term, which is 45. So that's 15 over 2 times 48. And you might be thinking, gosh, that's a gross number. It's not as bad as you think, because 2 and 48 have a 2 in common, so it's going to be 24. So really, you just have 15 times 24, which equals 360. So the sum of the first 15 terms that are multiples of 3 are 360. So as I've already stated, what's really nice about this new sum form is that we can use it to find summation without finding all the individual terms within our summation. So for this example, we have the sum of 5i minus 9 from I is 1 to 25. So the way that we did this in 8.1 is we find I of 1 and write it down, plus I of 2 and write it down, I of 3, I of 4, and we do that 25 times, which is a little bit tedious and a lot of stuff. So this new sum really, really is nice. And on the notes, I say to find the first 3 terms and the last term. That's really just so you get comfortable with the summation. But you really only need the first and the last term because we're just doing the exact same process that we've already been doing. So the first term, that's a of 1, would be when I is 1, because that's the first term. That's our starting point. So that's when I is 1. When I is 1, we have 5 times 1 minus 9, which equals a negative 4. Our last term in this case is a 25. That's when I is 25. So in this case, we have 5 times 25 minus 9, which equals 116. Now we do this just like we've been doing the other problems, because the process isn't going to change. We're finding the sum of the first 25 terms of this summation. So that equals n, which is 25 over 2, times the first term, which was negative 4, plus the last term, which is our 25th term, which was 116. That's 25 over 2 times 112. 2 and 112 will cancel and leave us with 56. So that's 25 times 56, which equals 1,400. We're going to do one final example, and I'm going to have to slide the dust down for this one. We're going to do the exact same thing. We're going to use our sum to evaluate our summation so that we don't have to write every single term of our summation out. And I will scroll so you can see it on your screen as well. Again, you really only need to find your first term and your last term because we're using the sum. The first term will always be what your lower limit is, and your last term will always be what your upper limit is for your summation. So my first term is a sub 1, and that's when I is 1. So that'll be 6 times 1 minus 11, which equals negative 5. My last term will be a sub 30. That's 6 times 30 minus 11, which equals 180 minus 11, which equals 169. So now I have my first term and my last term. So if I'm taking the sum of the first 30 terms, and I know it's the first 30 because that's how many, that's my upper limit, the sum of my first 30 terms, then that's going to be 30 over 2, because it's n over 2, times my first term, which was negative 5, plus my last term, which was 169. 30 divided by 2 is 15. Negative 5 plus 169 is 164. 15 times 64 equals 2460. I don't know why I put a comma there. 2,460. And that is really the end of chapter 8, or at least the material that you need to be exposed to for this class. And so that is 8.2.